Hey guys, we're going to do our notes on acceleration today. You guys are very familiar with acceleration because I know how you guys pull out of the parking lot. You know how to accelerate. So acceleration is typically thought of in our cars as stepping on our gas, but you have to remember that we also step on our brakes, and that's a deceleration, which is actually a kind of acceleration. They're considered similar. So definition is it's a rate of change of velocity. Our formula is the change in v over change in t, which we typically will write out the v final minus v initial. I will use that on the formula page. Some people will take that formula, which is a equals v final minus v initial over t, just kind of taking out the deltas. And they'll cross multiply both sides by t, so you get at equals vf minus vi, and then they'll plus vi to both sides. This is just one form you'll see. So you get vi plus at equals vf. So sometimes you'll see it, but it's the exact same formula. So here's our little list. I'm going to require you to make a list of things in the practice problems. So you have two allowed units, meters per second squared or kilometers per hour squared. Velocity will be meters per second or kilometers per hour. Basically, there's no minutes. You don't get to have minutes. We're going to go through and see how you do these. Excuse my typo here. So an object starts from rest. As soon as you see rest, you should think of it as 0. So initially, it's 0 meters per second. And after 20 seconds, well, seconds is time, 20 seconds, it reaches a velocity. So velocity that happens later is called final. It may not be the actual final velocity, but it's the one that happens later. So 54 meters per second. Calculate the acceleration. So acceleration is my question mark. All right, so we're using v final minus v initial over t. So we're going to take 54 minus 0 over 20. Okay, so let's just do this. Clear. On. You don't really have to do the 54 divided by 20. It's minus 0. So we get 2.7. Now think about it. This is meters per second, and this is seconds. You have meters per second, which is just rewritten as 2.7 meters per second squared. The fact that it's positive tells me I'm going faster. A train is initially traveling 100 kilometers per hour. That's initially, so 100 kilometers per hour. It slows at a constant rate to a velocity. So this is the later velocity. So think of it as the final, 40 kilometers per hour in 60 seconds. So that's the time. You want to basically identify every number as you go through. 60 seconds. What is the acceleration? So there's my question mark. So we have an issue with units. I have hours, and seconds, and I need to take care of that and fix it. So how do I do this? Well, 60 seconds is how much of an hour? Well, let's think about it. 1 hour is 60 minutes, and there's 60 seconds in each. So that's 3,600 seconds in an hour. So the way we do this is technically what you do in chemistry. I have 60 seconds, and I'm going to times it because I need it to be in hours. 1 hour is 3,600 seconds. Seconds will cancel, and so basically I'm taking 60 divided by 3,600. All right, so let's see what that is. 60 divided by 3,600. So I have this point. Oh, I'm going to go 3 decimals and go 0.017, just so we're all on the same page. 0.017 hours. Now I have the same units. Okay, what's the formula? V final minus V initial over T. So every time you do problems, I'm going to look for the list, the formula, and then your answers. Okay, so we have V final is 40 minus 100 over 0.017. Okay, let's do it. 40 minus 100 divided by 0.017. So we get this large number of negative 3, 5, 29.41. Remember, this was kilometers per hour and this was hours, so kilometers per hour squared. When you have kilometers per hours, you get large numbers. They tend to be like that. So another way that we can have some average velocity that's accelerating is if you literally just, let's get in your car and you just step on the gas and you go from 0 to 60. I don't even have a time unit. If I go from 0 to 60, my average is simply going to be the middle. So there's an average velocity formula that has to do with accelerating. And it's the initial plus the final simply divided by 2. So it's pretty simple. All right, so a watercraft accelerates uniformly from 25. So 25 is where it starts, so that has to be the initial. And later, again, it's not an end, it's just later, but we call it the final, it's 40 meters per second. So V average is my question mark. Okay, so I'm simply going to use the formula 25 plus 40 over 2. Let's work it out. 25 plus 40 equals, divided by 2, looks like 32.5. So 32.5 meters per second. Now, after we're done with the notes, I'm actually going to show you how we get these two formulas. But for right now, these are our third and fourth acceleration related formulas. And essentially you're going to use these to solve all sorts of problems. So a lot of times it's going to come down to deciding which formula to use. So this is why we make the lists. All right, so I'm going to have a car that's going to accelerate from, I can't type from apparently, 11 meters per second to 53. So I'm going to initially be 11, and then later I'm going to be 53. Again, it's not about really being final, it's just the one that's later. How much distance does it cover? That's a question mark. If it accelerates, remember, as soon as you see meters per second squared, that's an acceleration. So I have 13.5 meters per second squared. Everything's in seconds, everything's in meters. I don't need to convert anything. So which one of these formulas is going to work the best? Let's see. I have a VI, yes. Do I have the time? I do not have the time. Let's try the other formula. Let's see. Do I have V final? Yes. Do I have V initial? Yes. Do I have the A? Yes. So we're going to use the VF squared minus VI squared equals the 2AD. I call this one the 2AD formula. All right, so let's do this. So I have 53 squared minus 11 squared equals 2 times 13.5 times D. Let's work it out. This up a little bit. 53 squared minus, oops, minus 11 squared equals, well, and then I'm going to divide by 2 times this, so 13.5 times 2 is 27, so divided by 27, and I get 99, and I'll go 2 decimals, 99.56, and I go back to here to figure out the unit. This would be meters, so not quite 100. So this is the one I want you to do, and we are going to check it in a little bit in class, but I want you to make a list of the variables that are given, choose a formula, whichever one it is, we will put them on the formula page, and see what you can get for the distance. All right, thanks guys.